Let's do another example just to sharpen up our skills here. So example number 2, we will let the parameterization of t and theta be equal to t cosine theta, t sine theta, and t squared. This happens to be the parameterization for a paraboloid. And of course, t is going to be greater than or equal to 0, and theta is going to run greater than 0 and less than 2 pi. Okay, so let's go ahead and calculate things. We don't need to, actually, we don't even need to worry about what the surface is. I mean, it's nice to know what it is, but really we're just working algebraically. So let's just go ahead and do the calculus, do the math. So if we take dp d theta, let's do theta first. It doesn't matter what you take first. You're going to end up with minus t sine theta. You're going to end up with t cosine theta. And you're going to end up with 0. T cosine theta and 0. And let's go ahead and take dp dt. That's going to equal cosine theta, sine theta, and 2t. Now, when I go ahead and I take dp d theta cross dp dt, this vector cross that vector, I'm going to end up with my normal vector. Well, that's going to equal I, j, k, my symbolic representation, minus t sine theta. This is going to be t cosine theta. This is going to be 0. This is going to be cosine theta, this is going to be sine theta, and this is going to be 2t. I take the symbolic determinant of that, expanded along the first row. So now I'm going to move to the next page. When I do that, I'll go ahead and let you confirm what it is that I end up getting. I end up with the following. I end up with 2t squared cosine theta I plus 2t squared sine theta j plus t times k. And expressed in regular list notation without the ijk, I end up with 2t squared cosine theta, 2t squared sine theta, and t. This is my n. That's my normal vector. Now, if I want to take the norm, well, not a problem. Square of this, square root of this, square of this, square of this, square of this, all under the square root sign. You end up with 4t to the 4th cosine squared theta plus 4t to the 4th sine squared theta. And we like it when we see sine squared and cosine squared because that's going to equal 1 plus t squared all under the radical, and the cosine squared and the sine squared, I factor out the 4t to the 4th. I end up with 4t to the 4th plus t squared all under the radical. This gives me the norm, the length of that vector at a particular value of t. My normal vector is this one. Okay, it is a vector. This is the norm of that vector. It's the magnitude of that vector. It's the length of that vector. Now let's see what this looks like. I'm going to draw a paraboloid here. So we have something like this. And of course this is a three-dimensional paraboloid, but I will not put the axes on there. Well, there's going to be some particular curve that's going to go this way as you hold one of them. If you fix theta and vary t, you're going to get this thing. If you fix t and vary theta, you're going to get that thing. Well, this point right here, this is a particular p of t theta. You're going to get a tangent vector that way. This is going to be dp dt. you're going to get a tangent vector that way. That is the dp d theta. And when I take dp d theta cross dp dt, I end up with my normal vector to the surface. This is a vector as the surface changes, okay? This normal vector is always going to be perpendicular to it, no matter which. That's the whole idea. So it is perpendicular to that one, and it is perpendicular to that. And this happens to be Rn, which again is dp d theta cross dp dt. If you end up doing dp dt cross dp d theta, what you end up with is the vector going into the paraboloid. It's still normal to the surface, but it's just pointing in. That's it. This way instead of this way. It's just a question of orientation. Positive, negative. That's all it is. The only thing that changes is the sign. Okay, so that is tangent plane and normal vector to a surface. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.